Hello everyone, in this video I'm going to talk about another application layer protocol, which is the Dynamic Host Configuration Protocol. The acronym is DHCP. So the DHCP protocol is a very important protocol in the sense that it allows computers to acquire IP addresses dynamically. So the first thing when you have a PC, let's say you have a computer here assigned to connected to a network, PC1 connected to a network, and you have also other computers, PC2 and PC3. Of course, when using the TCP IP protocol stack, it's a must that this protocol should have, it's a must this protocol to have an IP address. So IP address here is very important to allow computers to identify themselves and to communicate. Without an IP address, computer will be considered as disconnected. Now, there are different ways of assigning IP address to a PC. Also, the first one is the static assignment. Static assignment, where you go to the PC and manually configure the IP address, subnet, mask, default gateway, IP address of DNS server, or at least, if you want this computer to communicate within the local area network, it should have the IP address and a subnet mask. Now, assigning manually IP address to PCs is good. It can be done if you have a small number of computers, but if you have a large number of PCs, it becomes a very tough process, difficult to assign. You can do it once, of course. You have 100 computers or 100 of PCs, nodes, printers, scanners, etc. All these devices connect to computers, so you can assign this once, and then after that it becomes a very big problem to manage the IP address, to add new IP address, removing all the IP address, etc. Now, the best way also is to, now you have also to think about whether what happens if you want to increase the number of network addresses, bring new network address, or change network address. What happens if you change the IP address of default gateway, if you change the IP address of DNS servers, and so on. So when you do any change and you have a large number of PCs and computers, so it becomes a tedious task. So that's why people, most of the case, people rely on DHCP, where they will get dynamic IP address from DHCP servers instead of visiting every PC and assigning the required network parameters. So the second way of assigning network IP address to computers will be the DHCP. So DHCP means that the computer will dynamically acquire IP address from a DHCP server. So as the other application protocols we have seen so far, the DHCP protocol follows the client-server paradigm. It follows the client-server paradigm, where you have a client on one side and you have a server on the other side. So here the client, so the DHCP client here is the one who is going to request an IP address, and the server, the DHCP server on the other side, is the one which is going to provide the IP address to the DHCP client. Okay, so far so good. Now, what will happen? First, we have to understand that since DHCP is an application layer protocol, so it relies on a transport layer, and the transport layer protocol used by DHCP is UDP. So it's UDP transport layer protocol, which means that DHCP is connectionless. Now, we have to add here, assume that these three PCs needs to acquire IP address automatically. Let me just represent the PC like this. I have PC1 connected to this LAN, other PCs, PC2 for example, I have PC3, and if I want these computers to get IP address dynamically, I need to add DHCP server. Okay, so I need to add a DHCP server. Let's say this is a DHCP server connected to the same LAN where PC1 is connected. Alright, so PC1 is the PC which is going to request an IP address from the DHCP server, so it should start the DHCP client process on its side. This DHCP client process started here. It will listen, it will use port 68, so this is UDP port 68 used by DHCP clients, and it needs to communicate with DHCP process, DHCP server process listening on port 67. Of course, remember here we are dealing with UDP transport layer protocol. Now, what happens in fact? The first thing PC1 will do is PC1 will send a DHCP Discover message. DHCP will send a packet of type DHCP Discover. And this packet here is broadcast to everybody. Don't forget, at this level here, PC1 does not have any IP address yet, so it needs to find out, and it is configured to act as a DHCP client. So PC1 is going to try to find out if there is any DHCP server by sending a DHCP Discover packet or message, and this message is broadcast to the whole network. Now you can ask a question: how come PC1 does not have an IP address? So how can it broadcast the message? Here the broadcast will occur at the level of the MAC address, layer 2 broadcast. Okay, layer 2, which means destination MAC address. The destination MAC address of this message will be something like FF. This is the notation used by Microsoft. So which means broadcast, okay? I can use this. And of course the source MAC address will be the MAC address of PC1. Right, so this message, DHCP Discover message, is going to be generated by PC1, and it's a broadcast to all computers on the same line. So every computer on the same line is going to listen to this message. Now who's going to reply? Of course, if there is an eventual DHCP server available, that DHCP server understands the message, DHCP Discover, and then it will say, hey, I'm here. It will send, let me just use a different color here. So the DHCP server will reply by sending a DHCP offer message. So depending on the way, the implementation of DHCP, this DHCP offer is going to go directly to the to PC1. So the source MAC address will be the MAC address of DHCP server, and the destination MAC address will be the MAC address of PC1. So PC1 is the target of this message DHCP offer, and in this offer the DHCP server will put some IP address X, Y, Z, A. Okay, it will offer some IP address to PC1. Now PC1 has obtained this IP address, but still it cannot use it because it has to send another message, which is DHCP Request, another DHCP message of type DHCP Request. Okay, and of course this DHCP request is also broadcast. It is broadcast using layer 2 addressing, MAC address, and it is a broadcast to all computers on the same LAN, all devices on the same LAN where this DHCP message is supposed to reach. Okay, so now this is a DHCP request. Say, okay, I obtained this, I have been offered this IP address XYZA, and this is, so it's going to inform everybody that it was offered the IP address XYZA, and it intends to use this IP address. So after it sends the DHCP request, the server which offered that IP address, this IP address, is going to send a DHCP message of type acknowledge. So, which means that yes, I acknowledge giving you or assigning to you this IP address definitely. So only after the DHCP acknowledgement is received by the clients, only after this DHCP acknowledgement is received by PC1, at this moment now, PC1 can use the offered IP address to communicate with other computers on the same LAN. Before that, no. Before that, still PC1 is considered not having IP address yet. It's still in the process of acquiring an IP address. So, DHCP protocol, or the interaction between DHCP client listening on UDP port 68 with the DHCP server listening at port 67, UDP port 67. This interaction is based on 4 different DHCP messages. The first message is DHCP Discover. Discover is broadcast to everybody on the same LAN. And the broadcast here is based on layer 2 addresses, which are the MAC address. So the destination MAC address is broadcast, as you see here, all FFFF, so all ones are set to 1. All bits are set to 1. And the DHCP server reply by sending, if it exists, if there is one DHCP server and it exists, it's going to reply by sending DHCP offer. Hey, I offer you this IP address, which is available on my pool of IP addresses to assign to DHCP clients. Look what happens now. The DHCP client is going to send a DHCP message of type request, which means that it will inform everybody that this is the IP address that it was offered, so it's going to commit itself to using this IP address. And the request here is broadcast as well, because it wants to inform everybody. And it cannot still now, the DHCP client cannot use the offered IP address until it receives DHCP acknowledgement from the DHCP server. At that time, once it is acknowledged, yes, you can use that IP address, or I acknowledge that this IP address is for you, then PC1 will get this IP address, that the protocol stack of PC1 will commit this IP address to PC1, will commit this IP address and start using it to communicate with other computers. So this is very important, that to understand that the IP address will come at this stage, and after the 4 different types of DHCP messages are done. Of course, the DHCP protocol is not, it has some complexity also. I will not go through that in this video, but at least explain here the basic. Now, some people might ask a question. Why the DHCP protocol does not content itself of using 2 messages, DHCP Discover, where the client will try to communicate with the available DHCP server, and then the DHCP server will send DHCP offer, and that's it. Okay, so the DHCP server will offer an IP address to the DHCP client, and then the process will stop here. The real reason behind this is that on a network you can have more than one DHCP server. So you can have, let's say, one DHCP server, let's say DHCP server number 1. You can have another DHCP server. Okay, let's call it DHCP server number 2. We can have another 3rd DHCP server. So depending on your asset, depending how much budget you have, servers, etc. So you can have many DHCP servers, basically to provide a kind of resiliency or redundancy. So imagine one DHCP server is down, or connection to that DHCP server is bad or not available. So all computers configured to use DHCP protocol will not be able to obtain IP address. The morning when you boot up your computer, it will not have any IP address. So computer will not be able to communicate or to connect. So it will be a big issue, a big problem. Now, here, when PC1 will send DHCP Discover, which is broadcast, everybody is going to hear this because this is broadcast, of course. Now, if there are more than one DHCP server on the same LAN, all of them are going to respond and give offers. All of them. I mean, if you have 2, 3, 4, 5 DHCP servers, all of the DHCP servers are going to make their offers. Of course, the first one will make an offer, IP address, and this offer will reach the DHCP client. What about the offers made by other DHCP servers? Of course, each one of them is going to send its own offer. Okay, let me just represent it here with the orange color. So this one will make an offer, and this one will make an offer. But the DHCP client has tendency to use the first offer received, the first received offer, so it's going to use it. And you notice here that the DHCP request is broadcast. Why? It's broadcast simply for the DHCP client to tell everybody that this is the IP address that I have chosen. This is the offered IP address that I will use from now on, that I decide to use, or I choose, or whatever. Now, the other DHCP server, they are going to receive this DHCP request message because it's broadcast. And since they understand that their IP addresses, let's say here IP address is 1.1.1.1, and here IP address offered is 1.1.1.2, and since they understand that their offered IP address has not been chosen by the DHCP client, so they will simply send back the IP address to the pool of IP address to be assigned to other DHCP clients in the future. Okay, so this is just a way to inform other possible DHCP servers, if more than one exists on the network, that their IP address have not been retained, have not been chosen by the PC, have not been selected, or Okay, so instead of keeping these IP address pending and waiting to go through the remaining process, okay, simply this DHCP server will return back this IP address to the original pool of IP addresses ready to be serving to serve future other DHCP clients in the future. That's why here the DHCP request is broadcast for this reason. And of course the DHCP client is not going to use any IP address yet unless it receives DHCP acknowledgement, because DHCP protocol there is always a possibility, there is also the possibility of DHCP server changing its mind, so it will send DHCP negative acknowledgement where so it's going to retract or remove back the IP address that it offered first. But of course I will not go through this side of the DHCP protocol. It's a little bit more complex, so I will just stick to these 4 messages or the basic messages generated between the DHCP clients and DHCP server. Now we have to understand one thing, is that once the DHCP server assign IP address to DHCP clients, so it's going to assign for a period of time. This is what we call the lease period. Okay, lease period. Okay, lease period where the server is going to say to the client, hey, I gave you this IP address, let's say for 8 hours. You borrow this IP address, or I lend you this IP address, or I lease you this IP address for 8 hours. So you can use it for 8 hours. Okay. Nowadays the lease period is longer than that, but let's say this is just for the sake of example. Now the client is going to use this lease period. Okay, it will use it until it reaches a point here. This is what we call the renewal period. The renewal period. What's renewal period? A renewal period here, the clients will contact the DHCP server and ask the DHCP server to extend the lease period. For example, here let's say it's 50%. Okay, 50%, which means after 4 hours, the client will ask the DHCP server to extend it to another 4 hours. 4 hours. Okay, 4 more hours. So here it has 4 hours left, and here you have 4 hours, which means that we are dealing with 8 hours. This is called the renewal period. Now, if the DHCP server is not under pressure and accepts, okay, no problem. Is going to extend the lease period by another 4 hours to make the sum of what is left here and the extended period equal to the lease period, which is 8 hours. Now, there is another situation where the lease period here is 8 hours. Okay, the lease period is 8 hours, and the server or the client reached the use of 50%, let's say. It will go into renewal period. However, the server does not want to renew or to extend the lease time, the lease period to the DHCP client. So the server does not accept, doesn't want to do that. So what happens, the client will keep on using the parameters assigned by the DHCP server until it reaches, let's say, until it reaches 87.5% of the original lease period. At that moment, the client will go into a process called the rebinding period. What is the rebinding period? It means that the client will try to communicate with will try to search or find another DHCP server on the net in order to acquire a new set of network parameters from that server. So since the first DHCP server did not accept to extend the lease, okay, so it will try, it knows that after when it reaches 8 hours of using the network parameters, the DHCP server will take back the network parameters that it's originally leased to the DHCP client. So now what happens is that the DHCP client will try to find another DHCP server, hopefully if there is more than one DHCP server. So it's going to hook up with that second DHCP server and get new set of network parameters, and stay connected to the network and communicate with other devices. Otherwise, if there is only single DHCP server and the one which did not accept to renew the lease period. So once the DHCP client will reach 8 hours here, then it's going to disconnect. It will return back the IP address to the DHCP server and will stay without any IP address, so it will not be able to communicate with it. Of course, this kind of scenario are very rare. It's very rare to happen. But for what you have seen here, we have seen the rebinding period. Rebinding period actually, the renewal period, sorry, I will start with the renewal period, which is equal to, renewal period here is equal to 50% of the lease period. Okay, this is the default value used by Microsoft. Okay, this is Microsoft. Okay, this is the default renewal period used by Microsoft, and you have the rebinding period. Rebinding period, okay, which is equal to 87.5%, and this is the default rebinding period used by Microsoft as well. So if you go to, okay, so if you go to other operating system like Linux, Unix, etc., okay, so they have different default values, and they give you, and there is also a possibility to change this default value to different renewal period and rebinding period to different values. Remember that this is not fixed value, 50% and 87.5 is just a default value used by Microsoft operating system. In Linux, Unix, they use different default values. This is one point. The second point, you can also change these default values just by going to the operating system and changing the values. So you have to do, you can do that, I mean, if you want. However, you can stick with default values. It's not a big problem. So I hope this video was useful. Thank you for listening.